Hi, in this video we will go through 2 full selections from start to finish using what we have covered in the last 7 videos. For the first example, we have been asked to make a selection for a heating circuit. We require a single head variable speed circulator. We have been advised that the flow rate has been calculated at 10 cubic meters per hour. The water temperature is 50 degrees Celsius. There will be 45 meters worth of new galvanized steel pipework with 4 90-degree bends. And finally, we have been asked to include external communication via Modbus. As we have been provided with the flow rate, but not the pressure requirements size the pump, we should first look to work out the frictional loss. We first need to add the details of the application. We know it's a closed loop circulator layout. We require 1 single head pump. The flow rate is 10 cubic meters per hour. And there is no static head due to the circuit being closed loop. We can also change the water temperature to 50 degrees Celsius. In the middle of the screen, we can add details on the pipework. So we select the material as galvanized steel, nominal pressure of PN16, and the pipework size of DN40. For this example, we'll be using new pipework. We can then add the total length of pipework, which is 45 meters. Finally, we know that there will be 4 90-degree bends, so we can add them to the frictional loss calculation. Once you are finished, click OK to bring you back to the home screen. The pressure required to overcome the frictional loss in the system will now appear in the total head box under duty point. As we know we need a variable speed circulator, we enter EcoCirc XL under the model or name field. To start the selection, click View Results. We are now given 19 results to filter through. We can click the Product tab at the top of the screen to sort from smallest to largest pump. To preview the curve, we click on the Display Curve button on the top right of the screen. Ideally, we should go for a pump with the duty point in the middle of the curve, close to the best efficiency point. Once we are happy with the selection, we can click on the model reference to move on to the selection screen. We now need to configure the product to allow for Modbus external communication. Click Configure, then down to Product Version, then from the drop-down menu, click Modbus RTU. As there are no more selections to be made for this project, we can download the spec sheets for the unit with our duty point added to the curve. You can do this by clicking PDF, Customize, then Download. For the second example, we have been asked by a colleague to make a selection for an end suction pump transferring water. We have been advised that the flow rate has been calculated at 55 cubic meters per hour and that the pressure required is 32 meters head. They require a selection for cast iron and stainless steel construction. Has requested to show the variable speed curves and to be sent a copy of the project under the project ID water transfer. As we have been provided with the flow rate and pressure, we can head straight to the selection. From the home screen, we enter the flow rate of 55 cubic meters an hour and the total head of 32 meters. Under the model or name field to the left, we can enter the model ranges for the selection, which are NSCE as a cast iron end suction pump and the ESHE as the stainless steel. You can enter more than one product range to carry out the search for multiple pump ranges. We then click View Results to move forward. We are now given 9 results to filter through, showing both the ESHE and NSCE models. We will start off with the NSCE models. We can click the Rated Power tab to filter from lowest to highest in terms of kilowatt size. Then, to preview the curve, we click on the displayed curve on the top right of the screen. Ideally, we should go for a pump with the duty point in the middle of the curve, close to the best efficiency point. Once we are happy with the selection, we can click on the model reference to move over to the selection screen. No modifications are needed to the standard product. However, we have been asked to show the variable speed curves. First, we need to change the diagram view to show just a single curve. So we select Selected Curve from the drop-down menu. Then from the Analyze tab, we click Multiple Speed Curves, then click Apply to add the curves in 5 Hz increments. Once we are happy with the selection, we should then create a project. Click Save to Project. Then under Create a New Project, add the project ID Water Transfer. Then click the Create and Add button to confirm. Now it's time to select the stainless steel option. Click back to search results. Then up to the Results tab in the top left. We now need to add a stainless steel pump, so we click on the suitable ESHE model. Xylect has remembered the duty and still shows the variable speed curves. When we are happy with the selection, we can then add this to the project. Click Save to Project in the top right. Then from the drop-down menu, click the project we previously started, Water Transfer. To confirm, click the Add button. Now that we are finished with the 2 pump selections, we want to view the project by clicking on View Project Details. We are now able to share the project with a colleague. Click Share and collaborate on the bottom right of the screen. Then add the email address of the user you wish to share the project with. Once you click Share Project, a confirmation email will be sent out advising that they have been included on a new project. This concludes the Xylect pump selection tutorial. Thank you for watching. If you have any further questions, please contact your local Xylem office.